Howdy, howdy, Keys Pre-Calculus. We're going to go over some more of section 4.3. We will finish it on Thursday. We didn't get very far in class today because it was a shortened bell and we were distracted by cotton candy on the wall. So anyway, we're going to go over a couple more examples. We defined what SOHCAHTOA means. In class, we looked at right triangle trigonometry versus the unit circle trigonometry. It's pretty much the same thing, but we're thinking of it, instead of thinking of it as x, y, and radius on a coordinate plane, we're thinking of it as sides opposite adjacent to a particular angle in a right triangle and the hypotenuse. Okay, so sine, the SOHCAHTOA, sine is the function of theta when you divide the opposite side from that angle theta by the hypotenuse in a right triangle. The cosine function is when you take the adjacent side of theta and divide it by the hypotenuse in that right triangle. And the tangent function is when you take the opposite side of the angle and divide it by the adjacent side of the side that's adjacent to the angle. And that will give you the tan function. We did an example in class where you were given a right triangle with legs of sizes 3 and 4, and you found the hypotenuse, which was 5, and then we just evaluated the sine functions of theta, not the sine functions, all 6 of the trigonometric functions of a chosen theta. And we did it for both the angles that were across from 4 and the angles that are across from 3. We did not do it for the 90-degree angle. We will talk about that a little later. But we're going to do 3 more examples. These examples are for some very special angles, the 45-degree angle, the 60-degree angle, and the 30-degree angle. It is important that you learn these and you memorize these because these are some of the most common angles that you will be dealing with in trigonometry. So we're going to go through them just as more examples of evaluating the sine functions at these particular angles. And then you need to commit them to memory. You do not need to write them on the back of your unit circle because they're essentially on the front of your unit circle. You can figure them out just by looking at them. But we're going to do it here together. And put all of the functions, all the trig functions on one nice neat little chart here that you can see. And then you can take them in your notes, you can commit them to memory, you can see how they work on your unit circle. Okay, and then you'll be able to do them for whatever size triangle you have, no matter what size the sides are or how long the sides are and the hypotenuse is, the angles won't change and you can evaluate the trig functions for those angles easily. So let's look at this triangle I have up here right now. I put it on a coordinate plane just so you can see how they relate, but we're going to be looking at this particular triangle. It has a 45-degree angle and a right angle. So we know that the other angle has to be also 45 degrees because 90 minus 45 is 45. And remember that these two opposite angles from the right angle have to be complementary. They're complements of each other. So they have to add up to be 90. And we also have talked about something you should have already learned to memorize is when you have a 45, 45, 90 triangle, it doesn't matter how long the sides are, they will be in a 1, 1 square root of 2 ratio. That means if this first side was 15, the second side of the leg would also be 15. So if x was 15, y would be 15, and your hypotenuse would be the square root of 2 times 15. But for simplicity's sake, we're just going to leave it as 1, 1 square root of 2. Because no matter what numbers we use here, they will reduce down to what we get in this problem. Okay, so what are the 6 trig functions of a 45-degree angle? We also need to keep in mind that a 45-degree angle is the same thing as saying a pi over 4 radian angle. So the sine of 45 degrees is going to be the same thing as saying the sine of pi over 4 radian. If you're calculating this on your calculator, though, you're going to need to have it in degrees or radians. If you're looking for degrees, you've got to choose the degree mode. If you're looking for it in radians, and when you see something with pi or without a degree sign in it, you know that it's going to be in radians, then you need to put your calculator in the radian mode so that you can calculate what the sine of pi over 4 is. If you have it, pi over 4 radian is. If you have it in degree, you'll get a different number. Okay, so let's go ahead, and we don't need to worry about that right now. We're just going to do this manually. So we remember that SOHCAHTOA, sine is opposite over hypotenuse. Well, the opposite side of this theta right here that I have marked is 1. And the hypotenuse is the square root of 2. So the sine of 45 degrees is 1 over the square root of 2. However, that's not in simplified form. When I rationalize the denominator, I'm going to end up getting square root of 2 over 2. So the sine of 45 degrees is the square root of 2 over 2, or the sine of pi over 4 is the square root of 2 over 2. So what's a cosine? Well, the cosine is going to be the adjacent side over the hypotenuse. Well, the adjacent side is also equivalent to 1. The hypotenuse is the square root of 2, so that reduces to square root of 2 over 2, or simplifies to that. So the cosine of 45 degrees, or the cosine of pi over 4, is the square root of 2 over 2. Don't want it in a decimal. Leave it in this irrational form, because that's more exact. Okay, now we're going to take the tangent of 45 degrees. Tangent is just going to be the opposite side of theta over the adjacent side of theta. Well, the opposite side of theta here is 1. The adjacent side of theta is 1. So it's really 1 over 1, which just reduces to 1. So the tangent of 45 degrees, or the tangent of pi over 4, is 1. Now let's do the reciprocal trig functions. I could just say, instead of SOHCAHTOA, I could say, CHO, chose, sha, ko, but I don't need to. I can just flip what I had before. I can flip my sine, I can flip my cosine, or I can flip my tangent, or I could say the cosecant is hypotenuse over opposite. However you want to do it. I think it's easier just to flip it. The reciprocal of 1 over square root of 2 is just the square root of 2. Same thing for secant of 45 degrees. It's just the reciprocal of 1 over square root of 2, which is square root of 2. And the reciprocal of 1 is 1. So here we have all 6 trig functions of a 45 degree angle. You need to memorize these. It is obvious when you look at your unit circle what they are. You can see it very clearly and very easily. However, if you memorize them, you're going to be able to work through things faster. So go ahead and start working on committing to memory the 6 trigonometric functions of 45 degrees, or the 6 trigonometric functions of pi over 4 radian. Okay, next we're going to move on to another special triangle, and this will be our 30, 60, 90 triangle. And we're going to look at all of the 6, or we're going to look at evaluating the 6 trigonometric functions at 60 degrees, or pi over 3 radian. Now, again, we have this triangle that I drew here. We've got 60 degrees as my theta. Okay, so let theta equal 60 degrees. But what's the other degree measure in here if it's a right triangle? Well, 90 minus 60 is 30. Because remember, these two opposite angles of the right angle of a right triangle have got to be complementary. They've got to add to be 90. So this is 30 degrees. But we're looking to evaluate theta, the sine functions of theta when theta is 60. But we need this other angle so we can find out our relationship, our side relationships. And remember, the side opposite the smallest angle in a 30, 60 degree 90 triangle, or the side opposite the 30 degree angle, is going to be the smallest side, and that's going to be the number 1. The hypotenuse in a 30, 60, 90 degree triangle is always going to be twice the smallest side. So that is going to be the length of 2. So my hypotenuse is 2. We're not doing this as a radius of 2. We're doing it as a radius of 1 and figuring out the other x's and y's. We're going to let my hypotenuse be 2. And then the side across from the 60 degree angle in a 30, 60, 90 triangle is going to be the square root of 3 times whatever that 30 degree, the side opposite 30 degrees is. So 1 times the square root of 3 is the square root of 3. And the square root of 3 is between 1 and 2. So the largest angle has the longest side, the smallest angle has the shortest side, and then the middle-sized angle has the middle-sized side. But now that we know these, we know our opposite. In this case, this is our opposite, this is our adjacent, and this is our hypotenuse when we're looking at this 60-degree angle. Therefore, we can use the SOHCAHTOA to just figure out what our 6 trig functions are. So the sine of 60 degrees, or pi over 3 radian, is the opposite, which is the square root of 3, over the hypotenuse, which is 2. And that's as simplified as you're going to get. The cosine of 60 degrees is the adjacent over the hypotenuse, which is going to be 1/2. Now, it doesn't matter if these numbers are 1, 2 square root of 3, or 2, 4, 2 square root of 3, or 9, 18, 9 square root of 3. It doesn't matter. Or even if you don't have a square root in there. If it's a 30, 60, 90 triangle, your trig function is always going to reduce to 3 square roots of 2. And cosine is always going to reduce to 1/2. It'll always reduce that way. So it doesn't matter what the sides are. That's why we're just choosing the simplest side. But anyway, back to tangent. Tangent is opposite over adjacent. So it's going to be the square root of 3 over 1, which just simplifies to the square root of 3. Pretty simple. Cosecant, secant, and cotangent are reciprocal functions, are going to be 2 over the square root of 3, which simplifies, because I have to multiply both sides, both the numerator and the denominator, by the square root of 3 to rationalize the denominator. So this will simplify to 2 square roots of 3 over 3. This is how you need to write it every time. 2 square roots of 3 over 3. And then this one is going to simplify to 2. And this one's going to simplify to, well, excuse, not simplify, this is going to be the reciprocal of 1 over the square root of 3, which simplifies to the square root of 3 over 3. All right, so here are the 6 trig functions when they're evaluated at 60 degrees or pi over 3 radian. Again, you need to commit these to memory. And now we're going to look at a 30, 60 degree triangle again, but this time our theta is going to be 30 degrees. So we're going to do the opposite. So if this is 30, this one is 60. And so our side lengths are going to be the same, but in a different place. So this would be the 1. Opposite the right angle would be 2, and the opposite the 60 degrees would be the square root of 3. So my x and y have switched, if you want to think of it as x and y, or my opposites and adjacents are different numbers. This is the opposite of theta, this is adjacent to theta, and this is a side, this is a hypotenuse. So the 1 is the side opposite 30 degrees, the 2 is the side opposite, adjacent to 30 degrees, and the 2 is the hypotenuse. So just using those, I can say the sine of 30 degrees is opposite over hypotenuse, which would be 1/2. The cosine of 30 degrees is the adjacent over hypotenuse, which is the square root of 3 over 2. And the tangent of 30 degrees, or the tangent of pi over 6 radian, is going to be opposite over adjacent, which is 1 over the square root of 3, which simplifies to the square root of 3 over 3 when I rationalize the denominator. And then when I take the reciprocal functions, the cosecant of 30 degrees, or pi over 6, will be 2. The secant of 30 degrees will be 2 over the square root of 3, which simplifies to 2 square roots of 3 over 3. And you can do the math at home on your own to figure it out if you don't see it right away. And then the reciprocal of tangent of 30 degrees is a cotangent of 30 degrees, which is the same thing as the square root of 3. So here are the 6 trig functions evaluated at 30 degrees. You need to go ahead and memorize these as well. It's important that you know them from memory, because you'll be able to work faster. But I also want you to go back and compare the trig functions at 30 degrees to the trig functions at 60 degrees. I zoomed out on the screen so you can see them together. Pause the video and look at them for a minute and see if you can find a comparison. See here how the sine of 60 degrees is equivalent to the cosine of 30 degrees? And can you see how the cosine of 60 degrees is equivalent to the sine of 30 degrees. Same is true for the cosine of 60 and the secant of 30 and the secant of 60 and the cosecant of 30. It is also true of the tangent of 60 and the cotangent of 30 and the cotangent of 60 and the tangent of 30. Do you notice how all of these are equivalent? Sine of 60 degrees is equivalent to the cosine of 30. How do 60 and 30 compare to each other? Well, we said they're in a triangle and they're angles that are opposite the right angle of a right triangle. So that means those two angles have got to be complementary because they have to add up to be 90 degrees in order to make 180 degrees in a triangle. They are complementary angles. That means that those functions are complementary functions, are co-functions of each other. So sine and cosine are co-functions, secant and cosecant are co-functions, and tangent and cotangent are co-functions. And as you can see when you evaluate these two charts, that the co-functions of complementary angles are equal to each other. Therefore, the following relationships are always going to be true. The sine of 90 degrees minus theta, or you could also say the sine of pi over 2, because that's equivalent to 90 degrees minus theta, is equal or equivalent to the cosine of theta, or the cosine of 90 degrees minus theta, or you can think of it as the cosine of pi over 2 minus theta. Those equal the sine of theta. We'll do an example so this becomes clear in a minute. The tangent of 90 degrees, sorry about that, is not 900, it was 90, minus theta, or you can think of it as the tangent of pi over 2 minus theta, is equivalent to the cotangent of theta. At the same time, the cotangent of 90 degrees minus theta, or the cotangent of pi over 2 minus theta, is equal to the tangent of theta. And then the same thing works for secant and cosecant. Those magically appeared. Those are at the bottom of page 269 in your book. You can write this on the back of your unit circle if you'd like. For your identities, just call them cofunctions. Okay, and here's an example using what we did before. If I said the sine of 60 degrees, we know that that is the square root of 3 over 2. We also learned that the cosine of 30 degrees is equal to the square root of 3 over 2. So if I say the sine of 90 minus, I'm going to use this one right here, 30 degrees, is equivalent to, because I'm using 90 minus whatever theta is, and I'm letting theta be 30, is equivalent to the cosine of theta, which is 30. Is that true? Well, what is 90 minus 30? 90 minus 30 is 60, right? And that is the same thing as a cosine of 60 degrees. Excuse me, cosine of 30 degrees. Sorry. And they're both going to be the square root of 3 over 2. Or I could say let theta be 60. So I would say the sine of 90 minus 60 should be the same thing as the cosine of 60. Well, that would make the the sine of 30. And we learned earlier that the sine of 30 degrees is 1/2, and the cosine of 60 degrees is also 1/2. You could evaluate it by drawing your triangle and figuring out SOHCAHTOA, or you could just memorize it. Okay? We will practice doing some of these examples and using this in class on Thursday. But so right now, you've been given enough to do your homework, the beginning of 4.2. I didn't break it up into 2 sections, but I'm going to let you do it in 2 sections. I put on the Canvas assignment what I wanted you to do for Thursday, and then you'll be able to finish the rest of it up this weekend after we use some of the identities, after we practice some of those problems. Okay? Y'all have a good next couple of days, and I will see you on Thursday.